Welcome to the Mr. Beacon podcast. There's massive value in getting visibility into where assets, things, inventory, products are in an omniscient fashion, and Bluetooth beacons have long promised that capability. When Apple announced iBeacon, the whole of the retail industry started thinking about how Bluetooth beacons could be used to improve the shopping experience, make money, and now it's spread to healthcare and so many other industries. People tend to focus on the tags, but actually it's the readers, it's the infrastructure, and it's the network of those readers that are some of the most complex things that need to be mastered. And solution providers that are looking at providing a turnkey solution, a complete solution, need to decide if they're going to make or buy the network and the firmware and the software required to make this work. Solving that problem for solution providers is what Simon Ford's Bleakon company has been focusing on. And so I've recorded what turned out to be a fascinating conversation with him. Simon is one of the most experienced, knowledgeable people in the Internet of Things industry. He's spent 17 years working at Arm, which is the processor design house that is basically designing the CPUs in billions and billions of devices that we use every day, from the processor in your phone, probably many of the processors in other things like cars and appliances. Arm is a fascinating multi-billion-dollar business. And it's really all centered around IP or intellectual property, the designs for these chips that are made by Apple and Qualcomm and Wiliot, my employer. So I had really two fascinating conversations with Simon. The first one was about Bleakon, and the second one was about his career and how he evolved his way to setting up the company that he leads today. I hope you enjoy it as much as I did. Well, Simon, welcome to the Mr. Beacon podcast.
Thanks, Steve. It's great to be here.
We've talked on and off at a variety of events, and I've always been fascinated by the work that you have done in the industry, your work at Arm, and you look at things in a very interesting way from lots of different perspectives. And so I'm fascinated by this, your move to start up your own company, Bleakon, and I'd love to hear a bit about what you're doing. What is Bleakon? If you can give us like the brief pitch, and then we'll drill into it.
Oh, absolutely, yeah. So I guess Bleakon, the company, is trying to unlock Bluetooth Low Energy, which is a very established, well-known technology, perhaps for an industry which is less well-known, which is sort of the IoT connectivity sort of space, rather than the sort of consumer technology space. And I think you're very familiar with this with Wiliot. You're using Bluetooth in your Bluetooth sense tags. But you're not alone. There's lots of companies who are really trying to exploit Bluetooth in, I guess, the arena where you'd more classically be thinking about like cellular connectivity, LoRa connectivity, things like that, for many, many good reasons that I'm sure we can explore. And that's just exploding. The Bleakon as a company is building Bluetooth Low Energy infrastructure to allow IoT connectivity over that transport. And our customers are using that technology in their products. So our customers look like technology companies building products to exploit that.
Okay, so it's less selling to enterprises and more selling to other people that are building solutions?
Absolutely, yeah. So, much like, you think of Arm. Arm is selling to the guys that are actually going to manufacture the chips. We're a company selling technology that's going to be integrated into a final product. So in the classic SaaS world, you might think of companies like a Stripe or a Twilio. You want to integrate payment, you turn to Stripe. Stripe doesn't sell to end customers; it sells to these service developers. You want to interact with the telecom system. That's Twilio that you're interfacing with those sorts of things. But if you're a cloud company, data company, an AI company wanting to integrate, with physical things, and those physical things happen to have constraints that could be really interesting, where Bluetooth could play, then that's what we're doing. So and that allowing these product companies that have cloud components to their product offering or their service offering to use Bluetooth to talk to the devices or the products out in the field. Yeah.
And so what are the elements of what you're selling?
The main thing that companies are looking for is to exploit the Bluetooth technology, in these use cases, because, you know very well, Bluetooth is an absolutely amazing, technology. There's tens of chip manufacturers making Bluetooth low energy chips already. It's very low power. It's very low cost. It works all over the world. All of these reasons, companies would like to use this technology, but just not in the consumer space, right? They want to use it for things like asset tracking and data within their products to, communicate with them. So the technology we're building at one level is almost like a different version of the Bluetooth stack. It's a different profile for the Bluetooth stack that operates less like a consumer one-to-one paired model, but more like a, cellular, Wi-Fi, LoRa type model. So we're providing that firmware to those companies so they can design it using standard off-the-shelf chips into their products. And then we're running infrastructure that actually allows that to communicate back into the cloud. So we can, luckily because Bluetooth is prevalent, we can enable, mobile phones to act as the hotspots for those Bluetooth devices. We can enable laptops and things like that to act as the hotspots for those devices, and obviously have physical bridges, like you would have a Wi-Fi bridge or a LoRa bridge that can bridge that into the cloud. And the combination of those sort of hotspots, as we call them, whether they're apps on a phone or a physical box, and the sort of cloud infrastructure that we're building and run, that gives a really practical way for someone who wants to embed a Bluetooth chip in their device. But the goal is to know where it is in the world, or communicate it, with their cloud service, their cloud backend. So that's how the technology fits together. And think of it as like a Stripe or a Twilio, but for more like a physical device.
And what sort of companies are looking for this kind of capability? They're building out a solution, and they don't have the in-depth firmware expertise, the networking software expertise. Who can you kind of give us some profiles of the sorts of companies that you see adopting this?
Of course, yeah. I mean, a good way to think about it is like, where are these companies coming from? So these might be companies that perhaps historically, perhaps they're already using Bluetooth for beacons, right? That you're very familiar with. They've got a device, they want to know where it is, but actually knowing more about it is interesting. So perhaps they've come from a more, tracking background. They've been building solutions that are tracking devices, but they want to know what's happening to that device. Is it overheating as it goes through a supply chain? Is it being dropped? So they're looking to go beyond just, I can see a device, I want to send data about this device, I want to understand about it. So there's that sort of world, which is very, very natural. Asset tracking, I suppose, becoming asset visibility, I suppose. And then over time, that will just become embedded into products rather than being discrete things you bolt on. So, at the moment, you've really pushed this down to stickers that you stick on something. In the product world, maybe that's embedded in the product itself. So, pretty obvious what those look like. And then you've got more, product, you'd think of as classic product companies that want to digitize. So think medical devices, think, products that perhaps weren't previously connected, and putting a cellular device in there just isn't possible. It doesn't make sense. And that sort of one-to-one wire replacement model of Bluetooth means Bluetooth doesn't make sense. It's not about pairing your phone with your Fitbit because you didn't want a wire between your wrist and your phone, which is kind of the Bluetooth pairing model. You really do want to communicate back to base. So that you can imagine all the sorts of industries that are looking at their products and thinking, actually, I want data out of this. I want to be able to update my firmware. I want to be able to understand if it's performing how it's meant to perform. Those sorts of things. So it's a pretty amazing ecosystem to be starting to peel back on, because there's a huge diversity of companies that if they could get connectivity into their product or onto their physical asset, this really opens up like the data side, which SaaS companies have taken for granted. Every product company in SaaS knows exactly what their product's doing, how it's being used, if it's breaking. And a lot of the people dealing with physical assets or physical products are kind of blind. So initially you can imagine it's the obvious things, a medical device that wants to actually report back to base. But over time, these things get more interesting. It's not just about the core data. It's about, well, is it being used properly? Is it actually meeting my customers' requirements? How do I fix it if it's not? How do I patch the security bug? All these sorts of things. So really interesting to see where it's getting picked up.
Yeah, so let's just go through the verticals where this might. Well, I'm sure there's almost an infinite number of verticals, but what are the main ones where you see this a need for what you're providing? So, healthcare, medical devices. That's always a really great market for IoT. It seems like one of the first places that you start. And you talked a bit about that, but can you add a few more specifics of the kinds of devices that you might want to embed this into?
Yeah. I mean, if you took something like the medical device, I guess again think of the two different types of companies. There's the one that this product they're trying to build. So there's a bunch of startups or established companies trying to bring in new product lines. The connectivity has kind of unlocked the product. So monitoring this, monitoring someone's vitals, or monitoring assets or things in a business sort of opens up this business. It wasn't possible before. And then the other side, I guess, is almost like companies that have gone through a digitization, but that digitization is pretty manual. So you have a sensing device or a monitoring device, but it's someone's job to go and read the thing, punch it into a spreadsheet or punch it into your phone or something like that. And actually, if you could automate that, you've taken away the work, but also you've made it a lot more reliable, potentially have a lot more visibility, and you can start bringing in a lot more data from your environment. That and of course people will start to see how AI starts to become very interesting in this, how you can look for patterns as well as just actually use the first order data. Yeah, and that applies to all sorts of things. So, I don't want to go through the sort of standard IoT gamut of things because it's the obvious sorts of things. So the way we think about it is less about the markets at the moment, especially as a technology company, but more about the type of journey that a lot of these companies are going on, and the use case often, and the classical IoT use case, I guess we've had for the last 10 years, is it's unlocking something new. If you had data, this product can now exist. If I could only sense that thing, I could do something. But I think Bluetooth is very interesting in that it can achieve a price point that actually starts you to do some of these higher order functions as well. So you can actually manage a device, understand if it's working, update it at very low cost, or even just understand how your product is being used in the field. So you're getting to the product analytics, data analytics, sort of the marketing team. So you've gone through the fundamental product offering, through the engineering team to the product and marketing team. And actually Bluetooth pulls that into the realm of possibility for a lot of things that just weren't viable before. So it's actually really exciting to see the type of people that are knocking on our door and the sort of ideas they're thinking about. But short term, actually, a lot of the opportunities we're seeing look like, I guess, quite classical IoT use cases. If I could sense this thing, if I could embed this technology and communicate this thing, I have a product. It's the first order property of the product. And I think certainly as we mature as a company and the market matures, I think some of that's going to move to the sort of second order, almost like higher order philosophical questions. So that's actually really exciting to see.
Well, what are the industries where you see this kind of IoT taking off? Because I think we all go through our professional lives with a mixture of optimism and euphoria and fear and panic about whether the market's taking off. What's your perspective on the state of the market and where there is an increasing need for this and where you've decided, probably not a great place to focus?
Yeah, I mean, I think the fact that so there's the sort of digitization, you want to digitize this data. I think getting it back to home base is the game changer at a cost point that actually makes it viable for someone to do it without having to send out, without it being an expensive technology, but also without being able to send out, an installation team and things like that. So, if you look at that sort of I'd say the first era of IoT, the first 10 years, a lot of gadgets, a lot of remote control, but also a lot of projects that, look good on paper, but actually when you think about the total economics of what it takes to deploy a product, so not just the cost of hardware, but you have to train people, you have to install it, you have to do these sorts of things. Some of those projects, the ideas were formed and the insights were formed, but they couldn't really execute. Whereas the consumer space has, always been about flushing out those sorts of costs, whether it's supply chain costs, installation costs, training costs, returns, all of these sorts of things. So I think, a lot of that learning is coming back into the industrial world. And it actually, we think a lot of our customers look less industrial actually, but more commercial, in the sense that they're a commercial environment. And that could even be, that could be in a hospital or something or a product. But the behaviors and the way that they're adopted look much more like a consumer technology, because one of the joys of what we're with Beacon and Bluetooth is, there's billions of phones and hand computers already out there that enable this technology, so we can just turn them on. That could be if someone wants coverage of their warehouse, turn your barcode scanners that happen to be based on Android into Beacon hotspots, and you have coverage of a warehouse. Or if you want to cover an office, well, all your laptops are already sat there. Just enable them, and they're done. And you're unlocking, these incredibly low-cost chips to talk to them. But so I think that sort of ability that changes the equation in terms of how you think about deployment. Because if you have to send a guy around to install it, well, then that can blow your model out the water. But if you can make it sort of a consumer onboarding experience for the end customer, that's the sort of thing that takes out those costs as well.
So like crowdsourcing with people's phones rather than sending an electrician out to install a bunch of hotspots.
Yeah, it's not so much the crowdsourcing aspect. It's just that, if you can design your product to deploy, if you're Starbucks and you want to deploy sensing in your fridges because you want to keep within health and safety constraints of et cetera,
mm-hmm.
if the staff just have, or someone, relatively switched on can deploy that, that's a lot cheaper than having to send out a van and train and things like that. And what you find with a lot of these data companies, they're OPEX driven. They're providing value to their customer. So it's an OPEX model. It's a subscription model, right? They're providing a service to their customer. And actually any upfront capital in cost of equipment, in cost of getting the equipment out there and manufactured and getting it online, that's all a barrier to actually giving the customer value. So anything you can do to reduce those costs really allows it to go straight through to the service, which is where the customer is getting the value. So a lot of the way we think about the bit, so Beacon has, we've already got these incredibly low cost chips that are already made in billions. So we're taking advantage of incredible economies of scale. It's already got Bluetooth is already a trusted brand. It's already all over the world. There's billions of handsets out there already. So there's that aspect, like amazing opportunity. But in terms of actually building the business, we're also looking, well, where does cost turn up? Where does capital cost turn up? Is that, whether that's NRE, how a supply chain works, how you have to manufacture a device, how do you deal with security and all of these things add to effectively the upfront cost of getting a solution out there. So a lot of our learnings over the years, we're trying to bring to bear in this, and of course more study as we talk to more customers. How do we just take more and more and more cost out of getting a solution working? And then once it's working as a business, we can operate as a service business. So if once the customer's getting value, that's a great time to get paid. And that makes us look much more like a classic SaaS business. Yeah, so that's it's really compatible with those types of businesses where perhaps, businesses that are more oriented towards spending a load of capital to deploy infrastructure, they tend to become those kind of businesses that support them as well, that there's upfront projects, capital projects, very expensive projects, which means high risk as well. And that money has to come from somewhere rather than coming from the customer who you're giving the value to as quickly as possible. So I really like, there's a lot of things here that are really exciting that mean that we can operate like a service business, but make that really, attractive for the end customer who fundamentally just wants to get going and getting the value out of the product. So anything we can do to align with that, I think, is really going to pay off. Yeah.
So getting actual hotspot devices, fixed Bluetooth readers that are running plugged into the wall or running on batteries is expensive. And is what you're saying that there are a large proportion of use cases that can just be addressed by having the network running on employees' phones? They kind of bring your own device to work, and when you walk past the fridge, will listen for the temperature readings from a sensor in the fridge. Is that the kind of
exactly?
Gist of it?
Yeah, and yeah. So I mean, what I think one of our observations, so there was a bunch of observations that led to realizing there really, there was an opportunity for the company because there was this problem that just repeatedly I would be looking at companies who had an amazing idea. They knew they wanted to use Bluetooth, and then 6 months later, they were an infrastructure company, and that's really actually quite depressing when you repeatedly see that. So that need is pretty obvious. But yeah, the things that kept coming up were, why can't I just use a phone? Why can't that just be the bridge, or whatever you want to call it? But in other situations, no, you really do want a physical gateway. And what we found is this sort of weird diversity of, people building devices with apps that were custom for that device. And it's basically you can't leverage much infrastructure when your infrastructure is custom. It knows about the product domain. And then you had these, gateway solutions, which were just doing whatever they wanted, but it had no consideration of, could you use that architecture on a phone? Does that even make sense? Beacon scanners and things like that. And yeah, I think it became obvious to me at one point that, if you could solve this architecture where it became interchangeable and it worked more like a roaming cellular network, and people could use the same architecture, but have a lot of flexibility in how they deployed, because in their domain, they could take advantage of, like you said, the maintenance staff walking around the hotel gives you effective coverage of every hotel room over the course of a day. It's intermittent, but it is there. But some people want dedicated coverage.
You are solving a problem that some people might underestimate. They might say, well, I'll just do it myself. What are the things that are hard that people may not have quite realized? So rather than just kind of contracting some software engineer out in China to knock up some software to do this, what are the things that they are underestimating that make this more challenging?
Oh, okay. So I think there's two aspects to that. So, at some point, this is technology, right? You can build technology. It's not about magic. But often what you find within companies is, they can only take it so far. So they underestimate, the complexity of how would you re-engineer the security model? How do you get that signed off? How's the topology work? Oh, we've kind of got an Android app working. Oh, but I hadn't really thought that Android has lots of variants and is on lots of different phones, and iOS as well. Oh, and I do actually want it running on Windows now. But we need a physical hotspot here, and that needs to be, so there's lots of this sort of underscoping of the problem and not realizing, and this is, especially if it's engineering driven, right? Because engineers don't know how to necessarily purchase things sometimes. It starts off small and you don't really realize what you're getting into, right? So that's a classic sort of engineering mistake. And fair enough. But even if you just assume everything and you're not making that mistake, which I think is a better position to take. Don't assume people make wrong decisions. Assume they make decisions based on all information being available to them, then yeah, when you build, you see this in ARM, lots of people were building processors. ARM didn't necessarily build the best processor, but it certainly finished it. It wrapped it up as a product, and that made it adoptable. So initially, companies that didn't have a processor or suddenly needed a processor in the corner of their chip, where you could spin up a team, you could spend 18 months doing this. And by the way, at the end of 18 months, you may or may not have what you need. And certainly you didn't get all the benefits of, other things around it. Or you could go and just get on with what you needed to do. So, I mean, that's classic business, right? So, forgetting whether people make good or bad decisions, I think fundamentally there's a lot of technology it takes to make something like this work and maintain it. It's 10 times harder actually to make it into a product rather than just be internal gaffer tape.
Yeah.
But if that can be then sold to 100 customers, well, then that's an amazing business, but it's also an amazing deal for everyone who just gets to adopt the learnings of all that technology and the robustness and things like that. So yeah, there's lots of hard things. There's lots of technical things. There's lots of things that take time. It's hard to hire people that have these skills, all of that sort of stuff. But when you boil it down, actually for a lot of companies, if you can reliably and risk-free make that problem go away and get on with what, you're getting your product out there, I mean, what an amazing opportunity for your company to be successful. Yeah, so it's no magic, I'm afraid.
So Simon, how did you get into computers? What was your first computer?
Oh, first computer, interesting. So I guess computers, very early computers, sort of like 86, like 86, the Acorn, if anyone from the UK would know that, actually, that, was made by Acorn computers that became ARM. Those sort of computers were around. My dad was involved in engineering, electronics, and then more computing and things like that. So I guess really, yeah, very early on, I mean, I can still remember in primary school, building robots, trying to hook them up to computers, because I think our primary school had a BBC, which is a big deal.
Where did you grow up?
So this was so I'm currently based in Cambridge in the UK, but this was in Somerset in the UK. So, down towards Cornwall, that direction for people that know. So yeah, grew up a very small primary school, BBC Micro in the corner. Yeah, I remember the sort of building, robots that were tethered and drawn around, and you work out how do you get signals out of the computer and drive this thing around. So that was like a primary school. So in the UK, I guess that's what, like, 8, 9. So it was quite, that was already, quite young. And then, yeah, doing a lot of electronics, making PCBs, drawing PCBs, etching them, programming PIC microcontrollers, like the early PIC microcontrollers, stuff like that in assembly, just like really early general interest in this sort of stuff, probably driven by the want. I mean, and I think this is quite common, usually driven by the want to make something, achieve something, and then learning how to do it, which I think is a great way to learn, right? You have a goal, and then you're trying to pick out, well, how do I achieve that? And actually, I think most, a lot of engineers, they start out that way they want to build a game. So I'm sure I built a load of random, pretty poor games and things like that. But that's what motivated them, right? They had something. They saw it was possible to do it. They found some insight that meant they could do it themselves. So I think for electronics, that was probably seeing my dad, who getting to pick up a soldering iron when I was very little. And for computing, again, similar things. Seeing the sort of software starting to happen, computers starting to happen, and things like that. So yeah, that's I guess how I got into it, and then it's just addictive, isn't it? And you keep learning.
Yeah, it's just so many layers to the onion. You can go up, down, sideways. So how did that evolve into your career? You studied it at school? Did you study it at university?
Yeah. So I mean, up until I guess university, yeah, it was all sort of home. I was sort of writing articles for magazines, building stuff, trying to work, that sort of stuff. And then I went to study at Southampton University, and for me that was actually a really interesting university, because rather than computer science being in maths and electronics being in physics, which is in that age was the sort of where a lot of places had it, Southampton, they had sort of observed that these were actually going, they were really important together, and actually there was a sort of computer science and electronics department, and it even had a fab. Projects there. We built transistors. We built AND gates. We built chip design. We built instruction sets for computers. We wrote assemblers, and actually fabbed a chip, got things running. So it was university where I think it changed from, it was more than a hobby. Like I was really studying this, but personally, to university where, you've done maths, you've done physics, you've done those sorts of things at college and go to university. And so I was at Southampton for 4 years doing that, which was a great experience in terms of giving you, foundations. And then I think one of the research projects that I was doing there, or one of my projects, which is about building asynchronous silicon, I somehow got that in front of one of the ARM fellows, which was very lucky. And actually my interview basically was turning up in a pub in Cambridge, talking to this guy who is an absolute legend. So really thankful for him. And coming into ARM, I think basically is the first sort of graduate hire into what was becoming an R&D group in ARM. Because ARM had, obviously this was about 2001 or something like that. So ARM was established. It was still very small, but it was established.
How many people would you say?
At least a few hundred by that time. Yeah. I mean, so I'd have to remember exactly, but yeah, I mean, it was definitely hundreds. I forget, probably like 500, 600. I don't remember. But got into there, started working in the R&D group as that was being formed with basically a bunch of really smart people who had built previous CPU cores for ARM and were looking at the next generation, and ARM realized it had to get ahead of the game and start planning what was coming next and things like that. And that became, so it was a research department, but it was very much, I think we used to call it like little r, big D. It was basically advanced product development, I think. But at some level, ARM in its entirety is an R&D company, right? It's designing things, and then licensing that technology. So at some level, most companies would see the whole of ARM as R&D, whereas ARM itself saw what we were doing as more advanced product development, and research was more academics, things that, if it was in industry, it'd be like what Microsoft research would do and things like that. We didn't really have that.
So ARM's based in Cambridge, right?
Yeah, well, that's where it grew up. Yeah. So, I mean, obviously, one of the amazing things about Cambridge, huge amount of talent, huge amount of research into computers, Acorn existing, which is, really what gave birth to ARM when it was looking to build, looking for a chip for its next generation Acorn computer. And that kind of led it down a path where it ended up designing its own, and there's a joint venture between, spinning that out with VLSI, with Apple, to build a processor. So that's where it came from. So yeah, in Cambridge, but I think, obviously grew it to some extent. It's still quite a small company, compared to, companies that have lots of, fabs and engineering or salespeople or things like that.
Right.
But I guess what's perhaps interesting is, lots of talent in Cambridge, but grew globally actually, because there's offices in the US and things like that. But I think perhaps what really set the tone for the company is there weren't really customers in the UK. So from day one, it was traveling outside of the UK to be with customers. And I think, I mean, this is my perspective and what I've learned from being in the company, that really shaped the DNA of parts of the DNA of the company about getting out there, getting in front of customers, spending time, and in some sense made it quite quickly a global company. I think, if you're doing business with America, but then you're doing another day you're in Japan, and then another day you're in Taiwan or something like that. Maybe you're in Europe. You're getting quite a different sense of how to work with different cultures, and ARM is at some level a company that relies on building a lot of trust with its customer. It's a sort of shared endeavor when you're building a new product that these other people are going to rely on. I think that was quite interesting in the DNA. So yes, it was based in Cambridge in the UK, but actually I think very quickly acted like a global company, and now I think that's reflected in the way it's operated ever since.
Fascinating, and this is such a great kind of commercial principle, but I sort of assume it was highly influenced by the academic environment of Cambridge and full of super smart people. But that's a great approach to driving any business. And I guess it's sort of partly a function of the business decision to basically license IP and designs. You can't really do that on your own. I guess you could, but it seems much better to do it with customers.
Yeah. I mean, obviously, there's this is a an area that's been studied quite well, I think, because in some sense the IP model. I mean, IP model in concept is not novel, but actually a company applying it so successfully, it's really is quite amazing what happened. I mean, there's others like Rambus and things that did similar things, but in a different area. But yeah, it's one that it's really, I think, an interesting case study to learn lots about how you build relationships, how you build trust, how in some sense you build a high margin business that's actually quite low risk. You're actually sharing risk across your customer base, but that's part of the value you're providing. And you're having the foresight to not try and overcharge for that, but charge enough, and it becomes really valuable over time. And it taught me a lot about patience as well, like how sometimes you have to to build something really special. Sometimes it does take a lot of patience, building relationships and things like that. So yeah, really quite an amazing company in many ways. Yeah.
I'm interested in how that has, and you touched on it, but how that drove you in setting up your own company, how that informed you, the things that you decided you wanted to do and wanted to not do based on, a substantial amount of time working in this incredibly successful company. I worked at Qualcomm for a while, not nearly as long as you at Arm, about 7 years. But one of the things that just really struck me about it was the core of Qualcomm was a small number of very, very successful lines of business. There was the patent business, the licensing of the intellectual property, basically getting a check every time a phone is made anywhere or sold anywhere in the world. Pretty good business. And then the other one is the chip business, and just finding a few parts that are you're just so good at that even companies that hate you have to buy your product. And it was so hard for any other business to compete with the numbers from the IP, the intellectual property, the patent licensing business. We used to joke that you could fire the 30,000 people and just have 100 lawyers that were cashing checks and have this amazing business, at least until the IP became, intellectual property became stale. So back to my question to you, how did your time at Arm influence your business decisions in starting up your own company?
Yeah, I mean, that's a massive question, right? So yeah, I mean, I was at Arm for 17 years and very lucky, I think. I mean, Arm in itself is an amazing environment for any engineer or any, to be honest, not just engineering, but anyone in that company. I mean, it's really an incredible company. But yeah, I was fortunate that, I got to work on and I guess be involved in very early stages or even start some projects there that in the early days, maybe it was a couple of us or something like that, but grew really large. And to have the opportunity to learn so much technically, so I got to work on transistors all the way up to chip design, architecture, compilers, in the end all the way through to like IoT services, right? So the ability to have the exposure to so many people with so much expertise, and the very a culture where actually talking to anyone was fine and helping each other out was fine was really powerful. So there's, I think, both the culture and the fortune to work on projects that actually became quite substantial and allowed me to go through a whole cycle from conception through to delivery into the market. I guess combined with my interest in just understanding and learning stuff and things like that, that gave me the opportunity to build a huge amount of technical expertise in how to do things right. One of the things that's interesting about Arm is you're building something, but you don't necessarily know exactly how your customer is going to use it. So it changes perhaps the contract between you and your customer to become incredibly defined and robust. because
and we're sort of assuming everyone understands who ARM is, but without having a whole episode on it, what's like in a few seconds, what does ARM do?
Okay, yeah. So, I mean, ARM at its roots is a company that designs processors, processors that weren't necessarily the things on your desktop. They were the things that got embedded in the corner of a chip to be the processor embedded in a device that didn't look like a computer. And obviously the thing that really that took off for ARM was mobile phones. So ARM designed the processors that chip companies like TI at the time would build a baseband and control processor for, let's say, a Nokia phone or something like that. So silicon design, computer architecture, compilers, all those sort of tools that you need. Such a really complex mix of technology that needs to be in place to allow someone to just take off the shelf and use in their own design. And I guess that's the sort of roots of the company is processor design. And obviously over time that's expanded into transistors and graphics processors and things like that. But yeah, fundamentally it's a design company that can sell its design to lots of other companies.
How do you design a transistor? Isn't it a transistor just a transistor?
Well, yeah, so you'd like to think so, but yeah, if you're trying to design transistors for different processes to try and achieve different trade-offs, it's quite a complex and artful process, especially if the physics and the processes haven't actually been tied down yet.
And the processes we're talking about are the manufacturing processes for silicon. It's a 22
Absolutely.
nanometer
Exactly.
TSMC process. The TSMC being the company that makes the chips in the fabs for companies like Apple and the like.
That's exactly right. Yeah. So it's effectively the drawing you put onto the silicon through a photographic process. Yeah, to make a switch. But that switch could be fast. But that might mean it takes a bit of power through leakage, or it might be, slow, but it's very power efficient. There's all these different trade-offs. It's a very interesting thing just to even build the building block that you're going to build logic out of. But yeah.
and so you were involved in designing transistors. That now makes sense. So thank you for that. But what are your sort of the biggest projects that you look back on that you contributed to when you were at ARM?
Yeah. So from research point of view, I touched on a bunch of things, but the first one that I really got involved in and I guess saw coming over the horizon was large amounts of data processing. So at the time, SIMD processing, single instruction multiple data processing. So I was doing a bunch of research on that with a couple of other folks, and around this is sort of pre-iPhone. So, but it's around the time when Nokia is sort of starting to think, can we get color? Can we get color screens? Can we start to even display images? Can we start to do video? Can we do audio? Things like that. So we were building. So I led what became the ARM v7 Neon architecture, which is almost like the expansion of the architecture to expand all these multimedia processing capabilities. Yeah. So so I was leading the architecture design. So design the computer architecture, the instruction set and things like that. And we were working on the compilers so that these could be coded. And then obviously with the team that was going to build that into the first processor, which is a processor called Tiger, actually built in Austin. So that's where that one was built. And that went kind of into the sort of first real smartphones, I guess. It was a really big bet for ARM. It was a massive step up. But yeah, that was an amazing project and got me in the door talking to, the likes of Nokia and Ericsson. Obviously at the time, because they were leaders in mobile at the time. That's where I learned about Wybree, actually, that became Bluetooth Low Energy.
So Bluetooth Low Energy was actually something else developed by who? Wybree was developed by?
I think there's bits of pieces, but I think it was Ericsson and people like that were doing, and Nokia were looking at this as well. They could envision this model of phones talking to peripherals. And Bluetooth Classic, as it stood, didn't really cut it. Yeah, so there was this project called Wybree, and over time, that evolved and then actually got absorbed into the Bluetooth standard. So that was my first discovery of that. But then I was also over in the US, talking to Qualcomm with what a team they had just acquired, which actually became the Snapdragon team. if you're familiar with Snapdragon. So that was really exciting, convincing them to take this new architecture we had designed.
So that was their big CPU brand. So we now have Snapdragon Stadium here in San Diego, which is where Qualcomm's headquarters.
Yeah, so at the time, this was an idea. I think it was an ex-IBM team that they had just acquired. So I was over there with a sales guy, basically. And this was really interesting to me, obviously a technical background, but to be in those meetings, talking to these people about why they should adopt this architecture, because, they weren't necessarily going to do this. And coming out and talking to the sales guy and realised that I'd really helped, yes, I've been working on the technology, but I'd helped make this actually come to exist in what became, Snapdragon. That was a really interesting thing. And that sort of realisation that it doesn't matter how much you do the technology, if it doesn't get out there, it doesn't matter. It's just, a fanciful project. So actually being involved not only in the technology, but then, how do you market it? How do you take it to market? I forget where I announced it, Full Processor Forum or something like that. So being on stage announcing this thing, very interesting. Hadn't done that before, hadn't talked to press before. But then to be in with, Motorola, Qualcomm, other companies you can imagine. Yeah, really, just a really, really interesting time. So an absolutely amazing project for me to see it right from the start through to it being, in a flagship product and working with so many amazing, engineers in compilers, in computer architecture and CPU design. It's such a privilege, really.
Yeah, great training for a emerging CEO, I imagine, and also just sort of touching on this. So ARM, you kind of license the ARM architecture, and you get a compiler as well. That's all part of the package that you get. So you didn't you work on the M0 processor as well? Was that?
Well, so I didn't work on the processor itself, but yeah, it's a good point. So I'd gone through that, which is this was all targeting the emergence of what became smartphones, right? Things like that. But I think ARM quite cleverly was it was also getting used in microcontrollers. And an internal project which was called SandCat at the time. So Tiger was the big meaty application processor. There was a SandCat project. And that was looking through the lens of, well, what if we designed a processor that was specifically designed for this emerging microcontroller market? And really, how far could you push that? And this was sort of in an era where I guess 32 bits certainly wasn't standard. And for most people, they were skeptical that why would you need 32 bits for a microcontroller? So that was an amazing project, again, done by some amazing people. And then, so early on in that, I got involved in, with a guy called Chris, building, well, what does the software ecosystem need to look like? Or how do you give, the way I thought about it is, how do you give the software ecosystem a kick? Because so many things need to change as the industry is going to go forward. And also, how do we make this new technology we're delivering accessible? Right, so that it can be adopted, take it to market. So yeah, we were building initially this Mbed project, which was software tools to make that kind of technology accessible. And over time, it grew more into operating systems and IoT services and networking and radio stacks and all that sorts of things. So again, another really fortunate opportunity to start with, a couple of people in what people thought was a cupboard. But then, go through that whole cycle to it growing and becoming a division and acquiring companies to build the components and really doing amazing stuff. And to be honest, that's the one that exposed me a lot to, companies building microcontroller IoT type devices, all the different radio standards that and love in the IoT. We had people working on most of them. And being in with those customers and understanding all the sort of pains they were seeing. Yeah, that was in some sense, that's the unfair advantage of building, the Beacon, the company I'm building now. Mm-hmm. We got to see so much of what's possible, but also what people's pains were and things like that. And just build yet more expertise among ourselves and, the connections and network. Another really quite amazing project to have the fortune to work on, really.
And what was the thing that made you decide you wanted to run your own company? Because you were at ARM for decades, right? You were for a long time.
Well, yeah. So it was about 17 years. So I think I'd set my goal. The project that we were building. I think I'd set a goal that I'll work on this for a long time. I tend to like working on things for a long time because I think, you know, it's the combination of patience and chipping away at a problem that certainly the types that I like. You know, you work on something for a long time, and people perhaps don't even understand why why you think this is the thing, but then it pays off. And you know, so I had the opportunity to work there, but the company, the division had got really big. It was about 300 people. I'd been lucky enough to be able to hire a bunch of really interesting, you know, product managers and things like that. And yeah, I guess I always wanted to, you know, do something else and in some sense take all the knowledge and connections I'd made and learnt, but also, as you were saying earlier, that, you know, my learnings of how can you build a great company with integrity, and how do you, you know, solve a problem in a really interesting way, and what does a product look like versus, I don't know, a pile of code or some consultancy. Yeah, and I really wanted, you know, it's partly a test as well, but at the same time, yeah, I just kept seeing this opportunity around Bluetooth, and we weren't able to fulfill that as Arm and the group that we were in. So yeah, it just felt like a really good thing to do. There's an itch to scratch, and it felt like a really good time to go and you know, yeah, try and build something again.
Wonderful. Well, I've been asking you a bunch of easy questions, maybe not easy for most people, but easy for you. But the hardest questions are, what are the 3 songs that have meaning to you and why?
Oh, interesting. Okay, so I guess there's loads of songs that would have meaning to me, but I'm going to pick some that are a little bit related to the world of, you know, what we're up to and stuff like that. So the first I'm going to choose is a song called All I Need, which is a Jacob Collier song. It features like Mahalia and Ty Dolla $ign or something like that. But anyway, Jacob Collier, really interesting artist, super multi-instrumentalist, sort of grew up in the YouTube era and sort of found fame by doing these sort of multi-track YouTube videos. I suspect some people might have seen them. I think that's how he got on the radar of Quincy Jones. So really talented person and really inspirational, I think, because, you know, really explores his art, really pushes it to the limit, very self-driven to get behind things and challenge things, but then very willing to share that knowledge. So one of the things that happened over lockdown is I found that he was doing live streams of Logic breakdowns, which is, Logic is the program where you assemble all these tracks. Yeah. And he was just sitting on YouTube for 2 hours explaining how he built all this stuff and his ideas, and it was just amazing to watch. And then he released this video called All I Need, which was him in a bathroom, I think, playing lots of different instruments, plus these acts that he'd bought, other people that he'd bought in. And it was such a joyous song, but also the story behind it, everything. It just really resonated with me that, you know, someone can be so, you know, they really study. This is something they've spent years and years studying, self-driven, self-motivated, still honest, and then sharing that with other people to inspire them. I just thought, I mean, for me, that's lovely. And yeah, so I think it doesn't really matter about the song, but yeah, that was one of the lockdown ones, I guess.
Wonderful.
You should go and check it out.
Great. Yeah, I'm
so he's got loads of albums out now. Yeah.
Yeah. Very cool. So what's the next one?
So the next one I'm going to choose is one called Many of Horror by a band called Biffy Clyro, which is a bit more of a sort of Scottish rock band. And the reason I chose this one is because, again, really interesting band. They turned up on my radar like when their first album came out when I was pretty young. Pretty harsh, really quite interesting, bit syncopated. But there's Simon Neil, obviously great name, but the main songwriter, writing these amazing songs, but they're quite inaccessible, to be honest. Yeah. And over time, just like this amazing songwriting machine. If you're into that sort of music, it's, you know, it's sort of rock, I suppose, and really quite interesting. Like lots of interesting stuff they've done. But the reason I chose the Many of Horror song is actually, if you know a program called X Factor. Mm-hmm. One of the UK, I think it was the UK I don't watch X Factor, but they actually did a cover of one of these songs, and it was a very, you know, very poppy thing. Mm-hmm. And I just thought that was really interesting because they must have had such a dilemma to give the rights to give this song to what is basically Simon Cowell, X Factor, whatever, totally off brand.
Yes.
And actually got a load of backlash about it at some level. But, two things happened. An amazing song that this band had written got out as a much more poppy song. This guy was very, I'm going to say successful, one-hit wonder, no doubt, but whatever. But I also think it probably allowed people to discover this band who, over time, are still doing really interesting stuff, but a bit more accessible.
Huh.
So that just reminded me about those sort of dilemmas you have, where it's like people talk about selling out, or do I take this wrong customer? Is this pulling us in this wrong direction? And those sort of dilemmas. And I often think when you're in those things thinking, is this the right path? Is this a zig, which is going to get me the zag? Or is this just a total off? That's the sort of song that makes me think about that.
Yeah.
Anyway.
And I think it's so interesting. They license their intellectual property, which is kind of resonates, echoes with your
I suppose so.
past,
I don't think about that level. Yeah, it's that dilemma. That dilemma of, is this a good choice? Is this on brand? I have no idea. Anyway,
yeah.
But just an amazing band and a prolific songwriter with a great name because he's called Simon.
Very good. And number 3.
Okay, so for that one, I think there's a song by a band called Faithless. If you've come across Faithless, a bit more dancey band, and the song is called Mass Destruction, and it's quite a political song actually. It's about war and it's a classic sort of angsty type thing. Very good song again, really good band if people don't know Faithless. But it's got a few lines in there, and I don't generally listen to lyrics if I'm honest. And one is it says inaction is a weapon of mass destruction. It says a few other things, but inaction is a weapon of mass destruction. And that really sticks with me in terms of how decisions are made, because I think, especially in bigger companies and things like that, often indecision isn't seen as a problem. And I think often it is. So there's a few things that I learned, so Mike Inglis in ARM used to say, do 10 things and spend the time fixing the one you got wrong. Or Jeff Bezos, had this thing about two-way and one-way doors. So, if it's a two-way door, you can go through the door. If it doesn't work out, you can go back. Don't overthink it. If it's a one-way door and you can't go back, as it's very hard to undo that decision, then really, that is the ones you want to spend the time on. And yeah, I mean, actually, ARM had a really great culture, and I think, lots of things good. And so this wasn't really one of the issues. Certainly not I saw in the core engineering, maybe in the sort of more operational parts of the business or support parts of the business. But yeah, indecision, I think, it is often not recognized as how painful not making a decision can be to, a person, a team, a company, or whatever. So yeah, that always resonates me in, challenge yourself. Am I overthinking this? Can I just make a decision and move on and I'll learn something and maybe I'll have to reverse it, but actually I made more net for progress? Or is this something that, no, this is a one way and it's very hard to go back, and therefore the level of those are the ones to really spend the time on. So that song always rings in the back of my head to remind me when I need to evaluate, are we in this sort of situation? Yeah.
And are you musical in the sense of, do you make music or?
Oh, well, I guess that's So I guess I grew up, I was a drummer. So, I mean, self-taught. So I wouldn't say particularly good, in a band, and, you have to advertise, you have to put posters up, you have to try and get people to come to your gigs, you have to drive to the gigs, you have to set up, you have to play a band, play a gig, all that sort of stuff, have a brand. So that was really interesting. Yeah. So I was a drummer, good enough to pull it off in a band, but, nothing special. And then, at some point over lockdown, I think it was a combination of the Jacob Collier stuff and finding a video a bit about some of the sort of music theory. I'd never liked rote learning. It just didn't inspire me. That actually got me thinking about, chords and construction and stuff in a way that I'd always been fascinated by music, but I'd never really found the way in that I enjoyed. I didn't like the standard teaching methods. So partly down lockdown, I just started messing around on piano. Like, I wouldn't say I'm good at it, but it's been really enjoyable experience. Just learning it almost like theory and chords and things like that. And that was inspired by a couple of YouTube celebrities, I suppose.
Well, I've really enjoyed listening to you talk. So thanks, Simon, for coming on the show. I really appreciate it.
Hey, no worries. It was great.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.